Hi, welcome back to another Java session. Today I'd like to extend a little bit on what we had discussed in the object-oriented programming video, and I want to talk a little bit about the constructors, how to instantiate objects, what happens when all those methods are called in. So this is a little bit more basic, but I just want to go through this just to make sure that everything is absolutely clear. In Java, as we probably have discussed in the past, a class is basically a blueprint of an object. So meaning that you can create many instances or many items that look exactly the same or that are exactly the same by just instantiating that object over and over and over. How do we do that? We define a class, and a class is just basically a structure of different types of objects. So if I was going to show you something like that, or at the very least the hierarchy. So we already discussed that you have members, which are basically variables and methods. So you might have a few functions and a few internal variables that could be either primitives or objects themselves, creating a much more complicated hierarchy of items. So for example, you can have this one being an int, this one could be a string, this would could be another object, and this would could be a double, as far as like the members go. And then from there, you could have a different hierarchy of objects that essentially break down into further items. And an object could actually be quite complicated as far as a tree structure goes. If we want to think of it as if it was a tree or something like that, where you have the main branch here, and each time that you have an object, that tree keeps expanding. The main thing about this is that when we are instantiating an object, we use the keyword new, and when we use a keyword new along with a class name, we are calling a constructor. If we're calling a constructor that has no arguments or it's empty, we're calling the default constructor. When we're calling a different constructor, it's just because the object relies on having data being initialized in the object so that it can actually function properly. In order for me to explain what an object is more in action, I want to first explain a data structure. So we've already talked about arrays and how they are in memory placed in a continuous order. You cannot change it. Everything has to be the same data type. And because of that, if you had a situation where your memory, it has enough space, but it doesn't have enough continuous space or contiguous space, you would have something like this, where this is your RAM, the representation of your RAM. And let's assume that we're going to create, we have 1, 2, 3, 4, 5, 6, 7. Let's assume that we have an object that it's like 3 elements long, right? We're going to reserve that to be our array. And we're going to use the red to represent what is this array. And then the program continues executing, and it fills in other areas in the memory. And then at some point, it will eject some of the objects that were created in the memory, because that's what it does, what Java does. There will be something more about garbage collector on Java 2, but we could probably be freeing out some part of the memory. And if we want to, let's assume that we wanted to clone this array to add an extra element. Technically we have 1, 2, 3 elements. And even if we wanted to clone it, right now we don't have any space to put it because an array is continuous. Also, in order for us to clone it, we need to deep copy it. We don't have the memory right now for that. So in the early days of computing, resources were a lot more limited, and computer scientists thought, well, wouldn't it be nice if we created something similar to an array without the limitations of the array? And the limitations of the array, as you guys remember, is that the size is fixed, that everything has to be continuous, and that everything has to be the same data type. And in this case, the same data type or not is irrelevant for this particular case. But the important thing about a linked list is that you could have an object that stores a certain particular value, let's call it in this case a string, and then it has a pointer to the next linked list node that is going to have another string, and so on until it finds nothing. So let me have the list, str, and then points the next one to nothing. So we have now a list where we have all those elements. So if we wanted to grow the array, the only thing that we need to do is to add it till the very end, which is a little bit more natural for all of us, or at least for how our mind works. So let's grab the red and represent the elements of the linked list. And let's also fill in some extra garbage in the memory. Allows us to display the linked list better. So we have our first element of the linked list and we have a pointer to the next element. So then we can fill it in and then point another element to the next one. And then if we wanted to add another one, then we can fill it in. There's more memory fragmentation, but also there is more memory is being utilized rather than just being wasted in non-utilizable slots. So knowing that a linked list, essentially, again, thinking about it as a structure, kind of like what we've been talking about, is you have a linked list element, or let's call it my linked list, and that is going to have a string that is going to hold a value, and then it's going to have another pointer to another my linked list, which is going to be called next. And the easier way to iterate on that or to count or everything is just to essentially go through the entire list and calculate all that until we find that this is empty. Let's create a basic linked list in here. So I'm going to call it my linked list, and I'm going to create a public. This is where I'm going to create a constructor because I need to have a value, and let's add a private string value. Let's say string v, and in the code we're going to say value or this dot value, which means this instance, remember what we talked about, the pointer to is, equals v. And now we created a list, and also we were going to do private my linked list next equals, well, so when we create this, when we are calling this method, we can do my linked list root, the root of the linked list, and we do equals new my linked list, and then we say a name, I don't know, let's say John. If we wanted to add an element to the linked list, we would add a method called public void add, and we would add, I don't know, we can even say that we're going to create another string because that's the one that we're going to pass in. And if you guys remember from this, we had a situation where in order for you to add it, you have to traverse it all the way till the end. So what I'm going to do in this thing is that I'm going to create my linked list. We're going to call it pointer because I wanted to point initially at this. So at the very beginning, because we're going to call it on the root, equals this. And then while pointer dot next different than null, then we're going to do my linked list new item. I'm going to call it new item equals new my linked list. And we're going to put whatever value from here. No, I'm going to put it at the very end and then say pointer dot next equals new item. In this case, where we're arriving here and we say, okay, is the next one null? No, then I'm gonna move the pointer to the next one. So what I'm going to do here, pointer equals pointer dot next. And with that, we know that we're gonna be adding the element to the ending of the list. So I can do root dot add, and then we can say Paul, and then root dot add George, and then root dot add Ringo. So if I then added a breakpoint here just to inspect what we're doing here, we have John, and then the value of next points to Paul, and then the value of next points to a new element that's called George, and then the last one to Ringo. Again, these we achieved it by moving the pointer to the next element in the list until we didn't find the element. So basically, if you want to visualize it somehow, is that we had this list, and the only thing that we had in here was this pointer called this. And then in order for us to traverse it, we said, okay, well, we're gonna point our pointer element to the same thing that this is pointing to. And then, while this guy is not null, then pointer is gonna go to pointer to wherever pointer.next is pointing. So the next iteration was gonna go to this, and then it's gonna check, is this one null? No? Okay, so then we're going to take it to the next one, and then is this one null? Okay, then we know that we've reached the end of the list. So when we've reached that end of the list, we append the new element at the very end of it. I wanna talk about one extra thing in this entire conversation. In this exercise, I want to go through the entire creation of an object. Let's just assume that we've got this class where I'm creating a square. Basically, I'm representing a square in a class that in a Cartesian plane, it's going to draw, I don't know, something like this. If we have the whiteboard, where we've been all through math classes where we're represented where this is X, this is Y, and then we would have all the positions where we can start it. So in this class, I'm saying, okay, let's draw a square that it is on position 1, 1, and then we can define also the sizes and stuff. So let's take this one to create the square class, and I'm just gonna copy and paste this entire object. And as this thing says, let's just trust the math of the object, because I don't want to have to explain this, but you can see that there's several members, X and Y, meaning the positions where we're going to start right here, the object. Then we're going to say the width. And in the case of a square, you only need width because a square is the same height and the same width. In our constructor, we're just saying, okay, let's just start from whatever positions that you're gonna pass it, because you need to start it somewhere. Then I have some convenience functions for setting the width of the square and even scaling it and even rotating it. So those are just essentially convenience functions. Given that class, this is just a very cheesy simulation that I'm gonna put. Let's assume that when we would create a new version of this square, a new item of this square, we're going to create it as 1, 1. And what that happens is that it calls the constructor where it says square double X pose and double Y pose. It replaces the values of what we're doing. And one thing I want you to notice is that in this area, and let's change the color so that it's a little brighter. So in this area where you can see the 1 and the 1, essentially it replaced, even though that we had ints here, it replaced it into floating point versions because it got casted because it's a double in here. So essentially, this got translated all the way to the beginning of that object, giving us this as a result. So then if we called in that object that we called first and we called scale it by 4.0, then it's going to call this function where this is the code. So replacing it with that 4.0, it becomes 1.0, which was the original width that we had on the previous step. Like if you remember here, we had a width of 1.0 because that's the default, and then it becomes 4 times as bigger because that's what we're telling it. So basically, it changes the entire size of the square. Now, if we added a second square, we can see it here that it's getting created, and it follows the same principles, but this is its own entity, has nothing to do with the other square. Then if we wanted to rotate it, basically then we would call it second.rotate and then pass a 45. So in the other video we discussed how there is inheritance and whatnot. So this is a perfect situation where we can use inheritance because a square is a rectangle that has the same dimensions. So what if we use the same class or the same code to represent both? So what I'm going to do is that I'm going then now to modify this class. I'm going to refactor the class. I'm going to right click and then go to the refactor menu and rename, and I'm going to name it rectangle. Now also, because a rectangle has a double height equals 1 and double width equals 1, we are then going to do the same thing where we're going to add another method that it's going to be set height and then double my height. So we are adding the height to the entire thing, and then also to this one we're adding height, and then this times height times factor. Okay, so now we have our a rectangle where we are changing the width and height. But before we had a square, and the square actually had the constraint of having the same width and height altogether. So what I'm going to do is that I'm going to create a class called square that extends from rectangle. Because the square has the condition that, and let's copy all this only, because it has a condition that in a square the width and the height have the same dimensions, we're going to modify this function to be this dot height equals my width, because we're going to modify the height and the width every time that we change the width, and we're going to modify the height and the width every time that we change the height. So I am doing basically this, where I am modifying both things. So now I gotta modify the constructor and then tell it super x pose and y pose. And now, so essentially we're calling the constructor of the rectangle class using this, and we are just restricting. So basically, again, because we're extending from rectangle, we're grabbing all the code that we already wrote here and putting it here automatically. The constructor doesn't get recreated. You need to create those. And because I wanted to do exactly the same as the parent class, what it did, I am just calling the parent class constructor by using the super keyword. Then on the width, I am changing the width and height, because that's a constraint for the square, and a width and height for the square. Basically, then if we go into our pattern, now we can see that when we create a rectangle, we're creating basically a square where both of those are the same width and height. For whatever reason, it's a square or it's a rectangle. It's the same thing at this point. The difference is that in the rectangle class, you have the option to change the height or the width. Then in this case, when we're setting the height, we are just essentially, instead of affecting the entire thing and scaling it uniformly, we're just scaling on one of the axes. As a last thing that I want to touch on is also I want to add another method to the overall rectangle. I want to add a GetArea method. Here's something that I want to emphasize. In a class like this, you end up having a return value when you're putting in a function. You have a return type, and the return value has to be of that type that you're going to return. So this multiplication of width times height is a double, and we can return it as a value. If you guys remember from your geometry classes, the area of a rectangle is essentially the multiplication of the width and the height. So if we are creating a square, in this particular case, where we're setting the height, and because in the height we're modifying the width and the height, whenever we call the GetArea, we're multiplying 4 times 4, and that is what gets returned. For this homework, we're going to utilize every single concept that we have been exploring. We're going to have an abstract class called polygon and an interface shape. So a polygon comes from the Greek multiple sides. Technically, a triangle is a shape, and we're defining shape in this context because we are saying, okay, give me the area and give me the perimeter. And then the polygon has basically sides. So that's why we have an array of sides in there. And there's an abstract method that says how many sides each class has. So for example, if it is a triangle, then we have to return 3. If it's a rectangle, then we'll have to return 4. In the case of a circle is not a polygon, it's just a shape. So we are going to have to just implement the shape, but not extend from the polygon. For the triangle and the rectangle, we have to extend from the polygon and implement the shape. In IntelliJ, there's whenever you are adding a shape and you need to implement all the methods, you can just Alt-Enter on the interface where it's going to have a red underlining that it's going to say that you need to implement such methods. You can select all the methods to create it and it will do most of the heavy weightlifting for you. And yeah, and basically that's today's lecture. I hope you guys are successful, and remember to send me any messages or comments so that I can help you or guide you in case that you guys are stuck. See you next time.